Hello, welcome back to KISH-CAT classes. I hope that you must have gone through the previous 4 videos made on divisibility rules. In this video, I'm going to solve questions where I'm going to take divisors as of the format 2 power x, 5 power x, 10 power x, and divisors 9, 11, or very rarely asked divisors like 7, 13, 37, and also divisors which are of the format 10 power x minus 1 and 10 power x plus 1. So in the previous videos, I've taken these divisors and I've explained clearly about how to apply these divisors, how to find the reminders when you use these divisors. That is 2 power x, 5 power x, 10 power x format of 3, 9, 11, 7, 13, 37. And the final ones are 10 power x minus 1 and 10 power x plus 1. Let's solve question number 1. N equal to 1, 2, 3, 1, 2, 3, 1, 2, 3 and up to 300 digits. Find the remainder when n is divided by. So I'm giving you all the divisors. I'm taking all the divisors. Now, do remember, there are two things that you need to remember and you need to observe them very closely before you solve the question. The one is, what is n here? How many digits are there in n? So this is the first one, the number of digits in n. Second one is like, observe the pattern of the digits. Here the number of digits is 300. Very good. And I've given the digits are 1, 2, 3, 1, 2, 3, 1, 2, 3, 123. So it means 1, 2, 3 appeared every single time. So 1, 2, 3, you can consider them as a cluster. Now the most important thing that you need to remember is, I have taken 1, 2, 3. It means if I'm going to change this 1, 2, 3 to 1, 2, 3, 4. Or if I'm going to take 5 numbers, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. We are going to get different answers. But do remember 1, 2, 3 is a fixed one. So it means we are trying to find answers for a fixed pattern one. Don't worry. Once we complete this question number 1, in the remaining questions we are going to take different numbers. We are going to do experiment with n. Now if n equal to 1, 2, 3, 1, 2, 3, 1, 2, 3 and divided by 300. So first one is when the divisors are 2, 4, 8. These are of the format 2 power n. Now how to solve? Find the remainder when n is a number and then it is divisible by a number like 2 power x. So 2 power x means it's 2, 4, 8 and so on. That's very simple. Now the remainder depends on, as I explained you, last x digits of n. In fact, for 5 power x also the same format, the last x digits of n, and the 10 power x, it is not just last x digits of n. It's not that it depends on last x digits of n, like last x digits exactly, or the reminders. If I say that x equal to 1, then it's last digits. If I say that x equal to last 2 digits are the reminders. Now here, if x equal to 2 power x, and then it just depends on last x digits of n. Now here n is given as 1, 2, 3, 1, 2, 3 and 300 digits. What is unit digits? That's what you need to know. Now it's 300 digits and it is cluster of 3, 3. It means that you can find that 100 clusters. So it means 1, 2, 3 and this is the last cluster which is the 100th cluster, which is also 1, 2, 3. Now n divided by 2, it depends on unit digit. So that is 3 by 2, the remainder is 1. Now if you want to divide by n by 4, since n by 4, that is a 4 is of the format 2 power x, x is 2, so we need to consider the last 2 digits. So last 2 digits of this number is 23, 23 by 2, 23 by 4, the remainder is 3. Now if you are trying to find the remainder for n, for divisor for 8 is of the format 2 power x, x is 3 here. It means that we need to consider the last 3 digits of the number. Last 3 digits are 123, 123 by 8, so the remainder is quite easy, 3. So simple. Now the next one is, there is a b here, is of the format 5 power n. Now n divided by 5 power n, as I explained you, for 5 power x you can take the last x digits of n. Here n we know that last digits are 1, 2, 3. So n by 5 is nothing but unit digit by 5. So the remainder is 3 here. Now n by 25, 25 is of the format 5 power 2. 5 power 2 means we need to take the last two digits, that is 23 by 25. So the remainder is 23. And finally n divided by 125. 125 is of the format 5 cube. It means that we need to consider last 3 digits. Last 3 digits are 1, 2, 3, 1, 2, 3 by 125. So the remainder itself is 123. So this must be very simple. Now C is n divided by 9 remainder. N divided by 9. Now if you have no idea about how to apply n divided by 9, the simple thing is it's like digits. That is like if I say that digits are PQRS, let's say that it's a 4-digit number PQRS, then this can be written as P000 plus Q00 plus R0 plus S, and this is down to P into 1000, that is 10Q plus Q into 10 square plus R into 10 power 1 plus S into 10 power 0, and this is divided by 9 because this is n divided by 9. Now in such a case we can directly say that it's P by 9 remainder into 10Q by 9 remainder. We can take this format and then so on up to S by 9 remainder into 10 power 0 by 9 remainder. So as a result, this is going to be 10 power 0 by 9 remainder is 1, S by 9 remainder depends on S, S into 1 is S, S by 9. The previous one is 10 power 1 by 9, the remainder is 1. R by 9 remainder is also 1, so 1 into R is R. So it's like this appears like this. So we need every digit, unlike n by 2, n by 4, where we needed only a few limited number of digits. However, here for n by 9 we need every digit. So every digit is multiplied by 1. So it's like sum of the digits P plus Q plus R plus S by 9. Now here in this number n equal to 1, 2, 3, and it's ended with 1, 2, 3. We have got 300 digits. So we need to add every digit. 300 digits. Adding every digit is really complex. But however, it's very easy here because the numbers appeared in a particular pattern. If the numbers appear randomly, then it's very difficult. Anyhow, for this question, it's 1 plus 2 plus 3 plus 1 plus 2 plus 3 and so on, 1 plus 2 plus 3 by 9. Here we can take that 1 is 60 times. So 1 appeared 60 times. 2 appeared 60 times. No, 1 appeared 100 times. 2 appeared 100 times. 3 appeared 100 times. Divided by 9. That's going to be 100 plus 200 plus 300. That is 600 by 9. Now no need to find that 600 by 9. You can still add 6 plus 0 plus 0 by 9. So the remainder is 6 here. Straightforward is simple. Or else you can do this one in different ways, that is n divided by 9 remainder. We have got 1, 2, 3, that is 123. So we have got 100 clusters or 100 clubs actually. Each club value is same, that is 123. So we can say 123 into 100. That's what we can do. So that's going to be 12,300 divided by 9. We can add 1 plus 2 plus 3 plus 0 plus 0 by 9. That's going to be 6 by 9. So the remainder is 6. Either we can add individual digits or we can take a club of 3, a club of 4, club of 5. Well, we can take any club size as anything. It could be 1, 2, 3, 4. It's our choice. Now same is the case with n by 11. So this is D. So n by 11 remainder. That's nothing but we know that it's P by 11 remainder into 10Q by 11 remainder and so on up to S by 11 remainder into 10 power 0 by 11 remainder. So that is nothing but at the end you get it's 11 by 9 plus that is minus R by 11 plus Q by 11 minus P by 11. So alternatively we are getting plus and minus. Why we are getting alternatively plus and minus is quite simple. What you need to do is like, first step is you need to take 10 power 0 by 11 remainder, that is plus 1. 10 power 1 by 11 remainder, that is 10, or else you can write it as minus 1. So 10 square by 11, the remainder is plus 1. 10 cube by 11, the remainder is minus 1. So we are getting plus 1 minus 1 alternatively. And since this number is like p into 10 cube plus q into 10 square plus r into 10 power 1 plus s into 10 power 0. So the first one is like 10 power 0 by 11, that's plus 1. So s is multiplied by plus 1. Whereas 10 power 1 by 11 remainder is minus 1. So r is multiplied by minus 1. 10 square by 11 remainder is plus 1. So q is multiplied by plus 1. So it means alternatively we are multiplying every digit by plus 1 minus 1. And since it starts with unit term, and unit term is multiplied by plus 1. So the remaining alternate terms are multiplied by minus 1 plus 1. So here we can write this as s plus q minus r plus p by 11. So sum of the alternate digits starting from unit term. That's it. Now let's apply this one. Let's apply the same one to solve our question. Our question is n equal to 1, 2, 3. 1, 2, 3, 1, 2, 3. And that's about 300 digits. And n divided by 11, we need to find the remainder. Now, it's quite simple. We need to take alternatively, starting from unit term. So, unit term is 3, and then alternate is 3 plus 1, and so on like this. So, that is 3 plus 1. And if I write this one, 1, 2, 3, that's going to be 3 plus 1 plus 2. So, that's going to be 3 plus 1 plus 2 plus 3 plus 1 plus 2, and so on like this. And the remaining alternate term starts from 2, 3, 1, then 2, 3, 1, that is 2 plus 3 plus 1 plus 2 plus 3 plus 1, and so on like this. And this divided by 11. Now the order is different, that's it. We are trying to add 3 plus 1 plus 2 only. Whether we are trying to add 3 plus 1 plus 2 or 2 plus 3 plus 1 or 1 plus 2 plus 3, the sum is same. So here in the first alternate club, we will get 150 terms. Here this is like 150 digits. In this 150 digits, 50 digits are 3, 50 more digits are 2, and then another 50 digits are 1. Same is the case here. We get 150 digits. This is also same. 2, 3, 1, they appeared 50 times. Each one appeared 50 times. That's it. So it means that both sums are equal. So in such a case 0. This 0 by 11, the remainder is 0. It's very simple. But should we really take? The most important thing is like, should we really take every single term? Every single digit? No. It's not needed. Now, these are like 1, 2, 3, 1, 2, 3, and 1, 2, 3, and so on, like 123. These are like 300 digits. Now, nothing but it's 100 clubs, or you can say clusters. Now, instead of 300, I'll solve this question a little later. What happens if we have what 1, 2, 3, 1, 2, 3, just only 6 digits and the 2 clusters? If you observe this one, it's going to be 3, 1, 2. Next 2, 3, 1. So it means that 3 plus 1 plus 2 is coming from 2 numbers, 2 clusters. That is 2 plus 3 plus 1 is coming from, that is the remaining alternate one. Now what happens if we add one more, if you add 2 more clubs? So look at this one. First alternative, again it starts from 3. There is a gap, it starts from 3. It's 1. Again it's 2. Now the next one starts from 2. It's 3. It's 1. Same thing. We are trying to add 3 plus 1 plus 2. And then we are trying to add 2 plus 3 plus 1. So instead of taking all the clubs into consideration, we have the flexibility of considering only 2 clubs. But do remember, here taking 2 clubs and adding the alternative terms will give the result as 0. Taking 4 clubs and adding the alternate digits also will give the result as 0. Taking 6, taking 8, taking 10, taking 200 clubs. So taking even number of clubs, the remainder is going to be 0. Yeah, remainder is going to be 0. So here 100 clubs, this is even. So if it is even, so n divided by 11, the remainder is going to be 0. The first thing is 100 clubs, and first thing what you need to do is like it's 100 clubs, it's even. The second thing you need to do is like club size is 3. The third thing that you need to remember is club value, that is same for all the clubs value is same, that is 1 2 3. Now I've done it by taking a club size of 3 3 actually. Well, if you are getting a club size of 4 4, club size of 5, club size of 6, actually you can easily define your methodology. That's very easy. So it's even number of clubs, remainder is 0. What happens if it's odd number of clubs? Let's take 1 2 3. That's going to be 3 plus 1, that is first one, minus 2. So that is fundamentally 4 minus 2. So that's going to be 2. Now what happens if we have covered 3 clubs? Do remember here, this one we can write as 3 plus 1 plus 2. That is 3 plus 1 plus 2. I haven't closed this one, that is 3 plus 1 plus 2. The next alternate club is going to be 2 plus 3 plus 1. That's going to be 2 plus 3 plus 1. Now, what we are trying to add to this 2 clubs. Now, for the other club, we are trying to add 3 plus 1. For this one, we are trying to add 3 plus 1. For the other one, we are trying to add only 2. Only 2 here. That's what we are trying to do. Now, these two are same, so it's get cancelled because it's minus sign, and this is 3 plus 1 minus 2. That means that we can cancel all the clubs, and then we can take only one single club here. Instead of taking every single club, we can eliminate all the even number of clubs. That is, if we have got 101 clubs, we can eliminate 100 clubs. 50 will go on the one side, the 50 will go on the other side, so both get cancelled. If the number of clubs are even, then the remainder is 0. If the number of clubs are odd, then we just need to take one single club. Yeah. Now let's take E. Now that is n divided by 7. N divided by 7 and 13. Absolutely 7 and 13. And we need to find the remainder. What we have learned in our third video is quite simple. The n is as usual, it's PQRS, and that is nothing but P into 10 cube plus Q into 10 square plus R into 10 power 1 plus S into 10 power 0. What I suggested you is, whenever you get a different remainder, a different divisor, how to find that remainder is quite simple. First, try to take 10 power 0 divided by that new divisor, which is 7 here. So that's going to be remainder plus 1. Now 10 power 1 divided by 7, the remainder is 3. 10 square by 7, the remainder is 2. 10 cube by 7, the remainder is 6. Now this remainder 6, you can write it as minus 1 also. Yeah, 6 by 7 is 6, it can be minus 1. 5 by 7 is 5, it can be minus 2. 4 by 7 is 4, or it can be minus 3. Now here we have got 10 cube by 7, the remainder is minus 1. Now when you get the remainders as 1, that's obviously, that's what we get when we take the first term, that is 10 power 0 by any divisor. The next time when we get remainder as 1, irrespective of the sign associated with it, whether it is plus 1 or minus 1, stop here. Now once you've reached plus 1, what you need to do is like you need to check the powers. So the power is 0 and the power is 3. Now it is the difference of the powers, that is 3 minus 0, that is 3. This is the club size. That's it. Now we need to divide the number into club of 3 3 starting from unit term. Here the number is 1 2 3 1 2 3 and so on, 1 2 3 1 2 3 1 2 3, and just like this 300. Now starting from the unit term, unit digit, we need to divide them into club of 3. This one club, second, third, fourth, and so on, like this. Now what we need to do is, like, we are very much comfortable with additions and subtractions, so I'm trying to convert the whole thing into additions and subtractions. Now for the first one, that is 123, that is multiplied by 10 power 0. Second one, 123, that is multiplied by 10 power 3, like this. It's multiplied by 10 power 0, this 10 cube, this 10 power 6, this 10 power 9, this 10 power 12, and so on. Now 10 power 0 divided by 7, remainder is plus 1. 10 power 3 by 7, remainder is minus 1. 10 power 6 by 7, the remainder is plus 1. 10 power 9 by 7, remainder is minus 1. So we are trying to see plus 1, minus 1. So every club is multiplied by either plus 1 or minus 1, but it is done in an alternative way, starting from plus 1 with the unit club. So it appears like this. So then that is 1, 2, 3, 1, 2, 3, 1, 2, 3, and so on. 1, 2, 3, 1, 2, 3, 1, 2, 3. This is going to be multiplied with plus 1, this is going to be multiplied with minus 1, this plus 1, and so on, like this. This is going to be minus 1, plus 1, minus 1. We'll get 100 clusters like this, or 100 clubs. 50 clubs are multiplied by plus 1, the remaining 50 clubs are multiplied by minus 1. In such a case, that's going to be 50 times 123 minus 50 times 123 divided by 7. The remainder is going to be 0. That's it. It's a very simple one. Once you know the application of it, once you know how to apply it, it's very, very easy. If we have got the clubs, that is the number of clubs or odd number of clubs, that's very easy. The first one will take 51 clubs, second one will take 50 clubs. So we are left with only one single club, that is 123 by 7. If the number of clubs are even, the remainder is going to be 0. If the number of clubs are odd, the remainder is going to be, remainder depends on only one single club. Now you have the flexibility of solving this question in a different way. Now instead of club of 3, 3, what happens if we get 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4? That's very easy. That's very, very easy. Let's see. We solve this one in a different way, and then I'll explain you what happens if we get a club size as a different one. Let's say this is n divided by 1, n divided by 7, and it's 123, like this. Now instead of dividing this one with a club of 3, 3, you can divide them in a club of 6, 6. Club of 6, 6 actually. So this club is multiplied by 10 power 0, this by 10 power 6, this by 10 power 12, and so on. Now 10 power 0 by 7, the remainder is plus 1. 10 power 6 by 7, the remainder is plus 1. 10 power 12 by 7, the remainder is plus 1. So it means this is nothing but 1, 2, 3, 1, 2, 3, plus 1, 2, 3, 1, 2, 3, plus and so on, 1, 2, 3, 1, 2, 3. That is 50 times divided by 7. That's going to be 50 times of 1, 2, 3, 1, 2, 3 divided by 7. Now we can take 50 by 7 remainder into 1, 2, 3, 1, 2, 3 by 7 remainder. So we just need to do calculation manually. That's going to be simple. Here the remainder is 1, and we just need to find the remainder here. If the remainder, the product of the remainders cannot be more than 7, if at all if it's more than 7, we just need to divide that number by 7 again. Now let's take what happens if, one moment, if n equal to, instead of 3 cluster size, it's going to be like this. That must be a bit difficult here. Remember, these kind of questions are not asked, never asked in CAT. Never. Now the club size is, let's say, now instead of taking 3, it would be better if we take 6, so that we can add all the clubs. Now the club size is 6, it's going to be 3, 4, 1, 2, 3, 4. Next one is 1, 2, 3, 4, 1, 2. Next one is 3, 4, 1, 2, 1, 2, 3, 4. So one club value is going to be 3, 4, 1, 2, 3, 4. The next club value is going to be 1, 2, 3, 4, 1, 2. So like this we will get, since the number of digits are 300 digits, and then since we are dividing them into a club of 6, 6, so we will get 50 clubs. So these are going to be 25 clubs and these are going to be 25 clubs. What happens if the number of the cluster size is not 4, cluster size is 5? If the cluster size is 5, what really happens is like, if instead of 1 2 3 4, what happens if it's 1 2 3 4 5? Then it's very easy. We just convert them into club of 6 6. Instead of 2 different clubs, we probably make it more number of different clubs. That's very easy. Do remember, these questions are yet to be asked in CAT. It's a very limited one. They've asked n divided by 7 only one time. I remember that they have asked only one time. It's all about n by 7, n by 5, n by 11, n by 9. N by 9 is also very rare. N by 11, n by 5, n by 4. These are very simple ones. Now, n by 13 is also same thing. That first you need to do 10 power 0 by 13. The remainder is plus 1. 10 power 1 by 13. The remainder is 10, or you can take minus 3. 10 square by 13. The remainder is 9. 10 cube by 13. The remainder is minus 1. Now, plus 1 minus 1. We have got 1 and 1. And the difference between the powers is 3 and 0. That is 3 minus 0. Now it is 3. This is club size. Now what we need to do is, we need to divide the number into club of 3 3 starting from unit term. Here the number is given as n equal to 1 2 3 1 2 3 and so on up to 1 2 3 1 2 3 300 digits. So once we divide them into club of 3 3, that's going to be one club, second club, third, 4, 5, 6. Like this we will get 100 clubs, where 50 clubs will take plus sign, remaining 50 clubs will take minus sign, and that happens alternatively. Starting from unit club we will get plus signs for alternative clubs, and for the remaining alternative clubs we will get minus signs. So since there are 100 clubs, 50 clubs will get plus sign and then 50 other will get minus sign. As a result, sum of one alternative and the sum of other alternative is same. So the remainder is going to be 0 by 13. That's it. Very easy. Let's start the final one, n divided by 37, and we need to find the remainder. Now here, whenever we get different divisor, I suggested you to follow the same thing, that is 10 power 0 by 37. The remainder is plus 1. 1 by 37. The remainder is 10. 10 square by 37. The remainder is 26. 10 cube by 37. The remainder is plus 1. Look at this. We have got reminders as plus 1 and plus 1, and the power difference between the powers is 3. So that is going to be 3 and 0. That's going to be 0 and minus 3. That is 3. This is the club size. Do remember, you have the flexibility. You can take club size as 3, or you can take the club size as a multiple of 3. That is 3 into 2, 3 into 3. 3 into an integer. That is the club size. Now, we just need to divide the number into club of 3 3. Now once you have divided the number into club of 3 3, what you need to do is, like, you just need to check the sign attached to reminders. Here the sign is plus for both of them. It means that plus for every club. We have got n equal to 1 2 3, 1 2 3 and so on, like 1 2 3 300 digits. This is club of 3 3, that is 100 clubs. Every club value is same. So if every club value is same, we need to just add every club, that is 1 2 3 plus 1 2 3 and so on up to 1 2 3 divided by 37. We have got 100 clubs like this. So 100 into 1 2 3 by 37. You can find the individual remainders, or you can stick to say that it's 12,300 divided by 37. Now you don't have to really find the remainder manually here. What you can do is, like, you can write this number as 0 1 300. Now you can divide them into club of 3 3. Now one club is 300 plus club is 12. So that is quite simple. 312 by 37. That's going to be 16. So I suggest you again and again, whenever you get a different remainder, your task is to divide 10 power 0, raise the 10 power from 0 to any number and try to find the reminders. When the reminders are 1 and 1, irrespective of the sign associated or attached with it, just find the reminders as 1 and 1. Once you found that the reminders are 1 and 1, check the powers. The difference between the powers is the club size. You have the flexibility of choosing the club size. You can take the club size as, let's say, if you found that club size is n, then you can take n, 2n, 3n, 4n, 5n as your club size. Now once you divide the number into club of, let's say 3 or 4, depends on your club size. Once you divided them into club of n, starting from unit term, then you check the sign. If it is +1, that's going to be every club will get plus sign. If it is +1, -1, alternate club starting from unit club will get plus sign. Remaining alternate clubs will get minus sign. One advantage is, if the clubs are even, then it's very easy. Except for 37, for 7 and 13, if the clubs are even numbers, then this remainder is 0. If the club is odd, we just need to consider only one club. That's very easy. Same is the case with 11 also. So we have solved question number 1. Let's move to question number 2. N equal to 846. 846. It's not 864. It's going to be 846. 846. 333 digits. Find the remainder when n is divided by 7. Now, quite simple. We know that n divided by 7. We know how to divide it. Now it's n divided by 7 remainder. That is 111 clubs. So obviously 51 clubs will get plus sign. 50 clubs will get minus sign. As a result, we are left with only one club. That is 333 divided by 7. So remainder is 4. Very easy. Now n divided by 11, we just need to find the remainder. As I told you, if n divided by 11, if the number of clubs are 111 clubs, so since it's like 100, that is even, and just one club, so we can take one club, that is 846. Now that's going to be 8 plus 6 minus 4 divided by 11, that is 14 minus 4 by 11, so that's going to be 10. So 10 is the remainder. That's very easy. So n by 7 also same thing. We can say that 100 even, so we can cancel, because out of 100 clubs, 50 are going to get plus sign, the remaining 50 will get minus sign. N divided by 37 remainder. It's very simple. We just need to add every single club. Here the number of clubs are 111. So 111 into 846 divided by 7. No need to multiply 846 with 111. So 111 divided by 7 remainder into 846 divided by 7, 11, not 7. 37 and then 37. Now 37 3s are 111, so the remainder is 0. 0 into some value x, that's going to be 0. Very easy, very simple. But do remember, 7 and 11, that's what we can expect in CAT. 37 is very rare, very rare. It never appeared in CAT. Now if you have got a number n equal to 1 5 zeros, again 1 5 zeros, like this we have got a 300 digit number. Find the remainder when n is divided by 13. So we have a big one, n divided by 13. So that is 1 5 zeros, 1 5 zeros, like this. At the end also 1 5 zeros, and we have got 300 digits. That's going to be 100 clubs. Because n divided by 13, we know that we need to divide them into club of 3 3. Alternate clubs will get plus sign, remaining alternate clubs will get minus sign. Here, this is the first one, this is the second one, and then other way also the same thing. So this is alternate one, and then we get the alternatively like this. So that's going to be this is how it happens. Look at this one. We are getting 100 clubs where each club is 3 size. value of one alternative is 000, that will get plus sign because it started from unit term. Value of other alternative is 100, that will get minus sign. So it means there are 50 clubs where the value is 000 minus there are 50 clubs where the value is 100 divided by 13. So as a result, this will be minus 5000 divided by 13. Forget about negative sign, just find the remainder for this one. That's going to be 5 into 10 cube divided by 13. So that means 5 into 5 by 13 remainder is 5 into 10 cube by 13 remainder is minus 1. So that's going to be minus of minus 5. So that's going to be 5. 5 is your remainder. Now you can find the answer in a different way. All of a sudden, instead of trying to add everything, you can change the club size here. Instead of taking club size as 3 and get confused with plus and minus, you can take the club size as 6. If the club size is 6, then it's very easy. Look at this one. As long as it's getting you are getting confused with this one, you have the flexibility of changing it so that you would be in a comfortable zone. Now instead of it 100 clubs, actually you can take club size as 6 size and then it's going to be 50 clubs. In such a case, this is going to be, the club size is going to be very easy. So club size is now 6 here. We just need to add everything because first club is multiplied by 10 power 0. Next club is multiplied by 10 power 6. The other one is multiplied by 10 power 12 and so on like this. So 10 power 0 by 13 remainder is 1. 10 power 6 by 13 remainder is 1. 10 power 12 by 13 remainder is 1. So we have got 50 clubs. 50 clubs into 10 power 5 divided by 13. This you can write as 5 into 10 power 6 divided by 13 remainder. Now that's nothing but 5 by 13 remainder into 10 power 6 by 13 remainder. We know that 5 by 13 remainder is 5 and 10 power 6 by 13 is plus 1. So that's going to be 5. This is the easiest one. Let's find the next one. So we have got one more question. So once we solve question number 4, we will have the last question. N equal to 10 10 10 10 10 10 like this 300 digits. Find the remainder when n is divided by 37. Now n divided by 37, we know the method. We need to divide the number into club of 3 3, or else you can divide the club of 6 6, club of 9 9. It's your choice. Here the number is 10 10 10 10 like this 300. That's going to be 10 10 10. Now the thing is, like, if you're trying to divide this number into club of 3 3, one club appears like 0 1 0, second club is going to be 1 0 1. That's a bit tricky because the club size is same but the club value is different. That is a bit, that may confuse you. It should not, but if at all if you're getting confused here, just you can simply take the club size as 6. If we take the club size as 6, very easy. Well, we'll stick with club size as 3. It means that 50 clubs, the value is 0 1 0. Another 50 clubs, the value is 1 0 1 1 0 1, and it's divided by 37. So that's going to be 50 times of 0 1 0 plus 1 0 1 divided by 37. That's going to be 50 times of 111 divided by 37. Now 50 by 37 remainder and 111 by 37 remainder. The good thing is 50 by 37 remainder is only 13, but 111 by 37 remainder is 0. So that's going to be 0. Now you can take club size as 6. So it means that we will get only 50 clubs where the club value is 101010. That's 1,10,10 into 50. That's what you can do. Let's move to the final one. When 10 power x is divided by 13, the remainder is 1. If x is a natural number less than 100, then how many values can x take? Very good one. Seems to be CAT pattern, CAT type of question, not of recent years of CAT, but possibly about 2005, 7, 8 type of exam, where the level of difficulty of quant section is way above of current standards. Now let's find it's 10 power x divided by 13. The remainder is plus 1. That's very easy. We know that if it's 10 power 0 by 13, the remainder is plus 1. What you just need to do, if you are not getting any clue here, is continuously try to divide 10 power some number by 13 in a proper order. That's going to be 10 power 1 by 13. The remainder is 10. 10 square by 13. What will you get? Remainder is 9. 10 cube by 13. The remainder is minus 1. Now 10 cube we are getting minus 1. In such a case, for 10 cube whole square by 13, the remainder is going to be minus 1 whole square. That means that it's going to be 3. Now this is nothing but 10 power 6. Now 10 power 9, what happens is 10 cube whole cube. So 10 power 9 is 10 cube whole cube divided by 13, that is minus 1 whole cube. We'll get minus 1 only. Now 10 cube whole power 4, that is 10 cube whole power of the even number, we could get to get remainder as plus 1. In fact, that's going to be 10 power 3 whole power even by 13, remainder is plus 1. Now instead of it, we can say this number is of the form, that is 10 cube is of the form, that's we can directly say that is 10 power 6k format divided by 13. Now the power must be less than 100 and it must be greater than 0 because natural number. So it means that k cannot take, so look at this one, k equal to 0 is ruled out. So it means that k equal to 1 to k equal to 16. When k equal to 1, the power is going to be 10 power 6. When k equal to 16, the power is going to be 96, which is the maximum value. So we can get 16 different values for x. That's how you need to understand the application part. Instead of trying to find the remainder, you should have a very good command over a number which is given in the pattern of 10 powers. 10 power x divided by 7, 10 power x divided by 9, 11, 13, 37, 99, 999, 101, 1001. Practice all these things and try to find how many, try to find the reminders and try to check when will they get plus 1, minus 1 reminders and try to see how many numbers are there if x lies between 0 and 100 and x is an integer. The good practice. So with this one, we have completed this session. I've taught you almost all the types of questions, and in fact we have taken different divisors, and in fact some of the divisors are yet to appear in CAT. Now the next thing is you just need to go through the original CAT questions of divisibility rules. They're very easy compared to these numbers. Very easy. Just solve all those original CAT questions which are given from 1992 to 2014, the last 25 years of CAT questions of divisibility rules. You can find the worksheet in the Facebook page of KISH CAT classes. Solve them and then observe the next video. So next video is going to be solutions for divisibility rules based questions appeared in CAT. Thank you.